Stanford University.
And so you've probably heard me say this at the beginning of all these lectures, so let's see if we can test you on it. What's the name of this class? DFJ, Entrepreneurial Thought Leader Lecture, brought to you every week by whom? STVP, the Stanford Technology Ventures Program, and BASIS, the Business Association of Stanford Engineering or Entrepreneurial Students. And it is brought to us online by the Stanford Center for Professional Development, and it is generously underwritten by DFJ. Okay, and you guys got to see Steve Jurvetson last week. It is my sincere pleasure today to welcome our esteemed guest, Greg Papadopoulos. And let me tell you a little bit about him. He's currently the CTO of Sun Microsystems. But when he was your age, he was a student. He started out at UC San Diego and then went on to MIT. And he stayed on at MIT, he got his master's and his PhD, and then stayed on as a faculty member where he taught CS and electrical engineering. He left MIT to go start several companies, and since 1994, he's been at Sun Microsystems as their Chief Technology Officer. He's got a terrific talk today called Citizen Engineer. Can't wait to hear it.
Okay. Thank you.
Take care.
Thank you.
Yep.
And I really appreciate the opportunity. So I'm kind of a high bandwidth sort of person. I do like being back here I saw the chalk back here. This dates back to when I used to lecture, was with chalk. And given the opportunity, I'm going to turn off all of this electronic stuff and start writing on the chalkboard. But in sort of the first part of this, I'm going to do a dangerous thing, which try to talk about 4 different things in a period of time that I should responsibly talk about one thing. But these are derived from a book that is just published within the last month with my co-author, and I don't see him here yet, David Douglas, who headed up is the Chief Sustainability Officer at Sun Microsystems. And the genesis of this was actually both Dave in his role of running sort of eco-responsibility at the company and now cloud computing. My job as CTO, a lot of that evangelizing around intellectual property and open source and network effects and the like. We've found that the engineers at the company, both people recently out of school as well as people been there for a long time, had some gaps. And the gaps in these areas of when we say, well, we really need to do something around sustainable engineering or positions on intellectual property, we found we were educating a lot. And so we decided to sort of short circuit this and go write a book. So we could go hand people things, go learn this, and then we'll have a conversation about what to do. So as I said, the 4 parts of this talk are that concept. So kind of taking those areas, principally eco-responsibility, the other one around intellectual responsibility, putting them together in sort of this rubric that we call citizen engineer. So this, sort of if you will, the first part is about this observation and the nature and the change in engineering. In sort of the 2 middle pieces are a little bit of a dive into an aspect of thinking about eco-engineering in I think a very constructive way. Another snippet is around intellectual property and open source, and then the final part is sort of things I've learned around managing innovation in the last dozen years. So there you go. 4 talks for the price of 1. First, let me just survey how many engineers in the audience people consider engineers. Excellent. How many people would say you're scientists? All right, first group are going to like the talk. The second group won't like this intro very much, so if you want to get up and leave, that's okay with me. The big picture observation of what's happened in the way we think about ideas or innovation, and I think if you looked at last century, what's on the left-hand side is sort of the evocative pieces, right? You think of scientists that are sort of toiling away inside companies, working on secret projects, and those go out and revolutionize or open up new markets for those companies, and very planned. And on the right-hand side is evocative of what I think what we all are living now and experiencing, which is very much I think what it means to be in a networked age. And that's what we're all living, and you are the digital natives here of the networking revolution that characterizes our generations. At the top of this, right, this is where you like it as an engineer. If last century was really the century of the scientist, this century is the century of the engineer. Right? And what is that? And what's an engineer? And maybe you're saying, why am I even doing this? Maybe another question, but I'll save that for later. An engineer is a constructive artist. And artists, it is, engineering is an interpretive form. You bring to it creativity. There's a real stereotype that people have of us, which is, everything's from a book, and you look it up and then you go do the next thing, and that's not at all true. There's a lot of sort of taste and experience that goes into it. And the central thing that you do, I mean, you use technological tools, but the central activity is this sort of optimization under constraints. So, I want to solve some problem, make it lighter, cheaper, better, more efficient, whatever it is, some new function, and here are the constraints. How much power it consumes, how much it costs, what are those constraints? That's the art of engineering. Oftentimes it's sort of like, and maybe this will help you too, when you have to explain the difference between a scientist and an engineer. And I look at, I'm a big space buff. One of my pastimes, I'm a trustee for the SETI Institute in Mountain View, which is truly a lot of fun. But Mars rover. So you look at it from a science side. It's talked about a lot. Go find, is there evidence of past water on Mars, maybe even life there? Okay, kind of interesting question. I like that question. Yeah, it's interesting science. Engineering. That's what this thing is in my mind. This is outstanding, right? These things have been up there for some 2,000 sols plus. And here's something, you build a robot that crawls around digging in the dirt of another planet. To me, that's way cool. This is a masterful feat of engineering. The science is maybe pedestrian there. One of my favorite quotes, speaking of JPL, from where the first director of JPL was Theodore von Karman. And I told you the scientists weren't going to like this too much. The scientist describes what is, the engineer creates what never was. And there's a lot in that. At the basic level, when I say engineering is a creative art, a constructive art. It is a constructive art. It is the construction of things, and I think that's what defines it. Okay, so all of that feel-good stuff. Things are changing, and again, the response of, well, what are the the gaps in the way we think about this in education in particular? There's some very big changes that you take a step back are a bit obvious. I mean, in the middle is this pervasive collaboration. That's the networking thing, right? Here's one of the greatest tools that we've invented in the last couple of generations, digital networking, and of course that has a lot of effect on the way that engineering itself is conducted. A whole new scale, and there are really two levels of this scale to think about. There's the nanoscale, being able to get down and obviously do atomic level manipulation of matter and think about that level. But there's also the scale of the amplification, which is the global scale of manufacture, production, distribution of products. And so you're able to engineer something and have that idea amplified very quickly, for better or for worse, across global markets. And all of this leads to a broader influence in engineering. And there are external changes too that buffet the art. Certainly everything around eco-engineering, I'll say more about that. Corporate social responsibility is one that you might not think about and come to mind. But this is, as a company, we are asked by our customers to demonstrate everything ranging from the ethics of our finances to our position, what labor looks like and how we treat people in the company, all the way to the ecology of our products. Here's the tough part. That question that gets asked of you is a transitive question, meaning that we have to answer that not just for what we do and control, but for the thousands and thousands of companies that supply to us. This is a big deal. Security and privacy, rise of digital goods, the tighter regulatory control, all of these are sort of these externalities, if you will, that buffet what we do. So this leads, as I said, kind of to this concept, if you will, this rubric of, well, how do you expect somebody, or what's the sort of role, be able to bridge these sets of concerns? And that comes up to this central notion of a citizen engineer, which we think of as this sort of bridge, if you will, between society and science. It's between this pure knowledge and how that knowledge is used. That's at least the ideal. And I'm going to give you some real sort of ideal things here, and then jump into sort of the two promised little meatier topics. But we really see these areas of, and again, these are pragmatic things that we find we have to teach in order to be able to meet the business needs that we're in. It's both eco, techno, if you will, intellectual responsibility, things around IP, and social. And the social is this transitive issue around social responsibility. If you want to become this in our mind, it means that your knowledge base has to grow, right? So the center of engineers' knowledge is the engineering itself. It's technology, right? And not to take anything away from that, but you really do have to understand and be able to interface with, and I think that's sort of the key concepts up here. Ecology, intellectual property, business, public policy, et cetera. Now I'm going to, and before you sort of scoff at some of this stuff, things like public policy or law or something, I want you to actually think, if you have these reactions sometimes about how people who aren't trained in science or engineering, can completely misunderstand something technically or scientifically. And you can go, oh my gosh, where did they go to school? What are they thinking, right? Well, some of those very same people might be thinking that of us about, what about, do you know how a law is made? How policy actually happens? Where did these people go to school? And so there's actually an obligation, and this is part of the duty here in our minds, is to understand those things and to reach out and be able to bridge that. And then finally, there's influence here, and I could go on about this. I'll give you an interesting statistic. If you look at the CEOs, the Spencer Stewart study of the CEOs of the Fortune 500, the number one undergraduate degree wasn't marketing, wasn't finance, wasn't business. It was engineering. As 20% of the CEOs of the Fortune 500 have engineering undergraduate degrees. So on to the two middle topics, right? So I'm going to spend time on sort of what we put as I think these organizing principles around environmental responsibility and then intellectual responsibility, so IP. So in the environmental responsibility, the thing we think sort of the key organizing principle here is really about thinking about life cycles of products. Right? So that's do you want to think about it? This is actually really key in some sense to distill this down, because when you get involved with eco, environmental, or a number of these issues, there are thousands or literally things that impinge on you at once. And how do you sort out? So product life cycles. This image here Okay, it goes to an article, a column that George Will wrote that was, well, his claim was if you were faced with the decision of buying a new car, you needed a new car, what you should do is get a used Hummer and find the nearest Prius and crush it. And the reasoning being that reusing that existing vehicle, no matter that even though it's less energy efficient or fuel efficient, has a lower environmental impact than the admittedly more fuel efficient Prius, but that you had to go manufacture and have all of the implications of the manufacturing, plus things like disposable batteries and what's the life cycle argument of the product. Now, there are a lot of reasons why there are flaws in that argument, but it's a really important one in particular. The differences aren't actually that big, and we can get into philosophy. I think you should buy Priuses because it sort of forward invests into the capital cycle of innovation around actually getting hybrids so that they are, in a life cycle sense, demonstrably better than existing cars. So let me go into this life cycle, dive into this a bit. And so on the left-hand side is a set of words: reduce, reuse, recycle, eco-efficiency. You all like that stuff? You hear it? It's kind of the food pyramid of the eco-efficient living world. I want you to forget it. Right? It's not that it's not important. It's just, in some sense, if you look at it, the left-hand side of this is really about making things less bad. And an engineering or a constructive way of it is, how do we make things good, or how do we make things better? And that is the life cycle view that we see the phases of life cycle as: you make a product, you use a product. This last phase is not recycling, it's about renewing the resources that you used in the product. Okay, so that I'm going to go into this right-hand side, sort of tear it apart. Right? The first step here is just going to kind of redraw the cycle a little bit differently for you, and plus give you the this is, by the way, if you haven't read Cradle to Cradle by McDonough and Braungart, you can read it literally a day on the beach. Okay, do it. It's really important. Go do it. And this is just taking, it's our interpretation of this. It was actually a very inspiring foundation for the work that we've done. So I'm just taking the cycle. And ignore the green arrow. Green is good now, right? That's a good color, so ignore it for a second. And I've just linearized you start with some resources and materials, if you will, the food for this process. You make something, you use it, and then at the end you ask, do I renew it? Or what's the end of that cycle? At the end of the cycle, I have essentially waste. Okay, now waste can be a good thing. So this is part of your recalibration and rethinking about this stuff. If you go through this cycle, you may look at depending on the product, the eco implications on this, or the ecological footprint of the product, could be very different. It could be that the manufacture of the product is where most of the impact is. It could be that it's its operation. So in our business, server computer systems, most of their ecological impact is in their use. It's the energy consumption over their lifetime. If you have your laptop, most of the eco impact is actually in its manufacturer, because they don't consume that much energy over their lifetime. And some things, maybe it's the e-waste at the end, or the landfill. So the important closing of this cycle is this green arrow. And the really key concept, according to McDonough and Braungart, is are you able to essentially upcycle this waste into something that's a useful resource to restart your cycle? And it's different than recycling, and often they will use the term recycle to be downcycling. Right? If you take some nice plastics that you build bottles out of and shred them up, and you get less nice stuff to go build clothing, right? That's not actually, that's downcycling. It's a degradation. It's degrading those materials as you go through the process. So it's almost an entropy argument here. How do you get this waste back into the cycle? And in their term, waste equals food. Okay, so just to really give you I think, at least for me, this is sort of the real insight about what's really going on in where we're messing up. And why we get into this, let's reduce everything because that will reduce the impact versus try to figure this out. So this is a constructive way of thinking about it. You really want to separate into two cycles. Biological cycles, right? Biological stuff, and that's stuff that's eaten by us or critters, right? And technical stuff. This is stuff that we are very important for our technical economy of building things like laptops and the like, right? And actually, the most important part about this, so you can think of this is mulching, right? And it's there's a solar cycle in here, there's a bunch of great stuff. This is, we're working on that one. Okay? And that's the engineering challenge for you all. It is, how do we really do this? Here's really is very important. It's a safety tip. Do not cross the streams. The really bad stuff happens is when waste from the technical waste, right? The rare earth stuff that we use that are very valuable over on this side, lead, get into this cycle. That's bad. That's pollution. That's a whole bunch of things that we don't like. Actually, if you want just a little further on this and thinking about it, the most important thing that you can do on the right-hand side is not just keep these waste streams out of this one. So you have an ability to sort of reclaim materials and bring them back up as raw materials, is that actually the purity of those materials are very important. Okay, so let me ground this for you, get it a little less abstract, is that when you say you have aluminum in something that you manufacture, we use aluminum for bezels or something on a computer. You want, when you're at the end of the lifetime of a machine and you want to renew that machine, you want to reclaim the metals that are in there, we learned something very simple, right? Don't put labels on the aluminum. Right? Just putting a sticker on a piece of aluminum actually degrades the value of the aluminum because you have to either clean it all off with some solvents and things and get it pure again, or it gets put into a lower part of the metal cycle. It's less useful as aluminum in the process. So really, from an engineering point of view, this process is of renewal. A very key part of that is you design for disassembly, and you design for what happens at the end of a product. And then if you really want to take this into a bigger idea that intersects with, I think, what the network age lets us do, it's converting products into services. So you could either buy computers and deal with this yourself, or it's the business plan actually to close that loop around renewal. So if you're getting your computing from a cloud computing provider, that provider can go be responsible for that entire cycle. Or you can imagine business models here, rather than sell water filters to somebody who then you use them and then discard them or something, sell them clean water. The service of, we'll sell you so many gallons metered through and we'll service the water filters, and you'll probably engineer a water filter that allows reuse and renewal in some ways. And there are many examples of that. At some point, cars could be treated like air transportation. Air transportation is a service that's delivered. We don't worry about the life cycle of the airplanes that we fly in, but you worry about the car that you drive. And then finally, these last views here, I think, are really important guidelines for us, because this is a big area to navigate. And at the sort of our distillation of what's important here is you got to stay legal. You got to understand what the laws are around the world, and they vary. Really focus on the business opportunities, because it is about return on investment in here that puts the fuel into the eco cycles in companies. But you do have to keep your eye on the biggest impacts, even if they're not by themselves business. The top business thing. For instance, we deal with taking lead out of, or hazardous materials out of electronics has been a big regulatory thing, which is, at some level, it's really unfortunate on an engineering side, because lead is an extremely useful electronic element. but it enters that biological cycle, right, through waste stream, so you got to stop. And always go after the low-hanging fruit. There's a lot of it here. Okay, so switching gears. Right? This is going into another aspect of this sort of rubric of engineering, and citizen engineering, techno responsibility or intellectual responsibility, and I would say not quite at the same power of a unifying principle, but it is one of particular personal opinion as well, is the importance of innovation networks and the importance of essentially building those models and thinking of integrating innovation that happens in other places and the network effects around innovation. And what is that? Innovation happens elsewhere, which is a Bill Joy quote. What does that mean? Or innovation happens everywhere is maybe the other way of thinking about it. If you're at a company, the smart people don't work only for you. Right? There are more smart people elsewhere. You have to recognize that, right? And this is the sort of Tom Sawyer thing. How do you get them to work on your stuff? What if you want other people to be? You want to be sort of a catalyst, right? How do you act in that catalytic way? You get them to work on it because it's cool, because it's free. That's key, because your stuff lets them do even cooler things, right? So how do you get that to happen? How do you get other people to work off of your ideas and build network effects around what you do? How do you do that? There's one simple idea. You make it free. And in the Richard Stallman sense, this is free as in freedom, not free as in beer, right? Much as that might be useful as well. And the free as in freedom is taking the ideas that you're working on and the artifacts and finding ways of sharing those, and sharing those in a way that invites other people to both participate and to riff their own, right? And this is certainly the basis of thinking in open source software. And I'll talk a little bit more about that. But there's a business thesis here, which is that this kind of sharing creates communities, right? And those communities extend beyond the walls of your company. That's really key, right? The communities can be of developers, they can be of users in the case of software. And those communities, their growth goes and creates markets, right? So once you have people adopting your technology or using it, or your service, something like YouTube is a great example of shared user communities, and there's a market there somewhere. You figure it out. So this comes back to, well, why do you need to know all this intellectual property stuff? How do you do this? It's actually, this is where using and understanding the legal system becomes a tool. And it becomes a tool that allows you to shape these communities in the way that you'd like. So, just sort of the 101 on that, for most of this stuff is really in the area of copyright law, right? And just for a quick review, patents protect ideas, copyrights are their expression, and trademarks are what you call them, right? And by the way, just because I get an opportunity to say this to you and you go, huh? If you don't, but if you have a patent on something, you don't have the right to make that thing. Hear what I said? If you have a patent on it, you don't have the right to make it. It gives you the right to exclude somebody else from making it. That's all a patent does. It's very powerful, all right? But the reason why you don't have a right is because you may read on somebody else's patents and thus cross-licenses. Copyrights are the expression of ideas. So that's like code, right? That's a good example of an expression. If you look at open source software, what the central mechanism for creating a community around that is a license. And the license is what you put in the preamble of the software. It's in the comments section of the code and things. That license is covered by copyright law. It says basically the license gives you a set of rules, like you may have to propagate this license, maybe you have to put back any changes that you've made or modifications or improvement, and may or may not deal with patents. depending on which license. It may say that, boy, if you're using this code and you want to keep using it, then you can't prosecute anybody on any patents that you have. And essentially, if you violate the license, you violate copyright law. And that allows people to go after you for copyright violations. So this is all about the freedom of sharing code. And that creates communities. One of the sort of the surprising thing is that model can be used to create communities in all kinds of ways. We've taken our Spark microprocessor code, which is hardware, but for anyone who's done hardware, you know that in fact it looks a lot like writing code. And we've taken the description of that hardware and actually placed it out, and it built growing communities out, starting with universities in academic settings, as well as companies that are adopting this code and building products from it. Here's some other interesting examples of this. And this is a startup chocolate company in San Francisco who's on the mission of making obsessively good chocolate, chocolates. That may appeal to people in here. They run it as an open source model in a very interesting way. The center of this is, hey, we don't really have much understanding or insight into even what people's flavor preferences around chocolate. Right? All you have is like the amount of cacao in the chocolate. How dark is it? Which is really like saying how much alcohol is in wine, right? That may be a preference, but it probably doesn't describe whether you're going to like wine or not. So they've developed this through user feedback of beta chocolate, this flavor wheel that has like 6 different kind of broad flavor areas in it, and they refine, you refine your palate, and they refine, the preferences of people about where the particular mixtures from beans from particular parts of the world end up. And so they beta test these things, and now they have 1.0 chocolate, and there's a bigger story there too about networks that they create. Here's another interesting one that is in a social sense interesting is there's a project called the Open Prosthetics Project that is basically after it started with how for people who have prosthetic arms is a lot of them have this thing called a Trautmann hook that was no longer manufactured, but everybody has to figure out how they're going to maintain it, how can they reproduce it, how can they improve it. And this is just a community of people who have come together to go share mechanical engineering designs and to sort of move forward the whole state of the art in prosthetics. And it's a very interesting example of building these communities in the mechanical engineering sense of things. So let me end here, and then we'll get into the Q&A with the last part of this. I call them axioms of innovation management, sort of where maybe I'm overinflating my insight into it, but these are at least sort of 8 things that I found important in managing or really in a real way fostering innovation. So this first one, I'm not going to belabor this. Right? This is one of those real, well, it's a philosophical thing about where are you going to send the time constants, and how ambitious are you going to be in innovation. But you really do have to think about this in the long term. I met some people here earlier who are over from Park and working on some long-term ideas in packaging of microelectronics, and we've had a project at Sun that invested well over $100 million in over the last 10 years, has yet to produce a single product, and we're going to keep investing in it because it is the potential that it has is unbelievable. So you look at, that's one extreme in the portfolio. Other ones are, well, you look at things that are going to produce something in 6 months. This is almost a McNeelyism. I think he just says conventional wisdom isn't. That's what Scott McNeely says, and it's certainly more of a lifestyle question than anything else. But I think if everybody believes in something, then you're probably too late to it. Right? That there particularly now, and I get, you really see these effects now, and I think it's part of the network age that we live in. You have an idea, it may be a really flamingly good idea. 6 months maybe is what your window is before sort of a bunch of other people have that idea. Right? But you know, if everybody believes it's true, the value's been extracted from it. You know, I'd like to think that you know, the organizations that I've helped manage from an innovation point of view are well, you know, all the great ideas come from, you know, these central labs or a small group of people, and it gets propagated down. No, not at all. The best ideas I've seen, certainly at Sun, have ones that have come up from individual engineering teams. I will say, as a manager, the thing that I get to do, and it's a real joy, is to try to identify those and kind of act as the magnet to pull them up through the organization and to help select them. What vision is a top-down thing. Vision is, back to the basics of engineering, is about a constraint system. It says we're kind of heading over in that direction, right? And here are the bumpers or Jersey barriers, right? We're not going to go into that market. We're not going over here. We're kind of in there, but okay, now go have fun and go innovate. One of my favorite Paul Sappho comments is you know, why the buildings in the valley are only 2 stories high and have grass all around them is so when people jump out of the buildings that they only sprain an ankle. And I think that's what, you know, a real important part of the valley is failure is really important part of the learning process. And you want to make, this may sound a little bit strange, but you want to make failure really cheap, right? And allow people to do it. That's sort of the process again of learning, because when you get the success, you get to go run with that too. I think it's a great cultural aspect. This is of the Valley. This is another one along these lines, which is disrupt thyself, and I mean disrupt in the Christensen sense of, I may, you know, have built the greatest technology and I think I'm on top of the world and I got it and everybody, you know, I just killed my competition in this, right? And I keep making that product better and better, and yet somebody comes along with a less good thing, but it's cheaper, simpler, easier to use, and it comes up underneath and disrupts what you do. You don't want that to happen to you. And if you don't want it to happen to you, you have to do it to yourself. Okay, so oftentimes you'll go in and say, God, I've got a cheaper way of doing this thing, I better go get it to market before somebody else does. Talking about one of, you know, in our co-opetition space, I think one of the most courageous things that Intel has done recently is the Atom microprocessor, people seen Atom, which is, you know, not as good as the sort of flagship microprocessors they do, but it's a lot less expensive and consumes a lot less power, and it's pretty good, and it's, you know, the netbook revolution. Right, has happened because of that. Trust me, Intel makes a lot less money off of each Atom than they do off of each Pentium. All right, but much better that Intel is doing it than AMD, say, from their perspective. This is sort of a very simple thing of you know, small, smart teams. You keep coming back to this, I think, and we keep rediscovering it in business cycles. But you know, teams are either 10 are really effective, 10 or fewer, or 100. And you may say, what's that about, Greg? What's that? All right, it's actually one level of management. You can get everybody in one room and there's one leader for the team. That's the 10. Or, right, there's 2. There's essentially one team of managers and fan out from there. You build projects that are larger than this, it's really hard. All right, because the management overhead really starts to get in the way. You have to be very good if you're going to run larger teams than that. Technology transfer is a context sport. This is sort of looking at this from a lab's point of view, if you will, or advanced development into how do you get it into products. in contact. This is contact sport like rugby is contact sport, not like ballroom dancing is a contact sport. And it means that people have to go across that boundary. So if any of you aspire to be in a research or advanced development labs, and you want to have an effect on product, number one way of having that effect is leave the labs with your idea and go into the product group. Become one of them. And finally here, it is all about the right people. This is, if I close the loop on this conversation, it's the constructive art. We are constructive artists with our life experiences in there, and it's how, it's how good are the people. And, ideas can be whatever, but it's about people making it happen. And I will end with what would be number 9, and then I decided, this is really more of a life philosophy. So I'll end with this and open it up to questions. And solving problems is a negative thing, right? It's, in some sense, there is a problem, I solve it, what did you do? And we talk about society a lot in problem solving terms. That's fine, problems are there that do need to be solved. The affirmative way of thinking about this is that you may see a problem and get inspired by it, but your job is to go create possibilities. It's creating opportunities, it's imagining, right, things that have never existed. So with that, I thank you for taking 4 talks in the space of 1, and I think we're opening up for questions. Thank you.
So thank you, Greg. As some of you have attended these lectures before know, this year first questions are taken from the MS&E 278 Spirit of Entrepreneurship class, which surrounds this class and offers greater depth of study of each one of the speakers' companies. So Greg, unbeknownst to you, we're going to be dissecting Sun.
Oh, excellent.
Both before and after this class. So let me start with the first question from the class. Given you joined Sun a decade after it was a scrappy little startup, but your title was still managing R&D. How does R&D differ in a company 12 years past its scrappy days versus what you would do in a startup?
Well, let's just for the record, so I did a number of startups before, and I never imagined myself at a big company for the length of time I've been there, for sure. I ended up in Sun through an acquisition of a company I was working with, thinking machines in Cambridge. And I like startups because of the focus. And if you say scrappy, it's really about you're single-minded about it. The problem in startups is about, typically, is not a technological one. It's about the machinery that you have to wrap around it, from sales and business development and a whole bunch of things like that. And so the advantage of a big company is that you get sales teams and all of that. The attraction to me for Sun was I saw sort of startup mentality still, meaning small teams, crazy ideas, and all that, in the context of a large amplifier. Right? So if you had your idea could get amplified by the sales force and all of the customers that were already there. And to me, that's kind of a magical thing. It was actually that experience and seeing that at the beginning is a thing that I've tried to maintain at Sun. And I think that's a difficult thing to do as companies mature. You tend to do the big, huge machine teams.
And that segues into the second question from the class. I almost feel sorry for the engineer who asked it, but he said that most engineers will spend their lives toiling in obscurity and with their products never seeing the light of day, at least for mass adoption. I thought that was I felt despondent after I actually read that question. But what advice do you give first of all, do you agree with that? And if so, what advice do you give to engineers who realize that they will be a cog in a machine in a large company like Sun? It was a student's question.
So the student who asked that question, can I give you some career counseling about maybe another career to talk about? There is first of all, I don't believe that's the experience of engineers, most engineers, and that's part of. I think vital companies are ones that you do get to see your ideas out there. I will give you a big hint. that building external communities and open source and all that is a great way of amplifying ideas and not toiling in obscurity, but in fact leading communities. So put that in. I would, however, caution against the companies who advertise, we're going to get your idea to market no matter what. I had that personal experience. It was 1994. I'm afraid how young many of you were at that time. But for the history books, it was a time when silicon graphics was on top of the world. And I was out here. I actually had an equivalent offer from Silicon Graphics and Sun. And Sun was sort of in the downside at the point in time. People thought Sun's dead, never going to come back. Microsoft's killing Sun. That was the second Sun death, 94. And I had, as I said, at Silicon Graphics, they did the Nintendo 64, which is coming out, Jurassic Park, which was rendered on SGI systems. They were on top of the world. And I remember going back, because I was still on the faculty at MIT, I was on leave, and I went back to the faculty lunch, and I said, I'm leaving, thank you, I loved it, so long, thanks for all the fish. I am going to Sun. And people go, you're crazy, why aren't you going to SGI? And I'll tell you why I didn't. Because when, this story does close, is that when I was interviewing at SGI with the president of SGI at the time, at the end of the interview, I was feeling pretty good. But at the end of the interview, he said to me, he said, and one thing I want to tell you, we know you're interviewing at Sun or they're making you an offer. You can be at Sun and working on a project for up to the point it's going to ship, and they'll cancel it. You work at SGI, I promise that whatever project you're working on, it's going to see its way to market. And that convinced me not to work for SGI. And I said, if you don't have the courage to figure out what's going to make it in the market or not, or be able to make a business decision, I don't want to be at that company.
Great answer. Thank you. Last question from the class, and then we'll open up to the audience. So get your other questions ready. Last question for the class was, has the current economic downturn, do you believe, affected the rate of innovation both at Sun and other places in Silicon Valley?
Yeah, I think innovation loves a crisis. Right? So I think that it increases the rate of overall innovation because there are lots of opportunities that get created. The large-scale sort of R&D portfolios certainly get hit on that, and I think the more effective things are how do you go actually do innovation in a very focused, very inexpensive way. And I think that there are lots and lots of tools now, and again, things like networking if you're into kind of software ideas, but people seeing like Tech Shop. Now, ever heard about that? In Menlo Park is sort of a place where you can go do a whole bunch of mechanical engineering and development and use machine tools and things in a very open, shared environment. So I think that innovation increases in these times, but you don't see it by measuring sort of the dollars that large companies put into it.
Great. So let's open up the questions to the floor. If you have some questions, just come on up or raise your hand. And I'll call on you. Questions? Questions for Greg? Yes.
As the transition of semiconductors to kind of less and less speed performance per node occurs, what happens with the kind of the economic drive that drove things for the last 50 years?
So people, the question is about the economic cycle that has driven semiconductor investment, and now looks like they're tapering off, and that. So first of all, I want to emphasize that things like Moore's law are not laws of physics. We know that, right? Semiconductors just don't sort of spontaneously double their density every 18 months. That's a techno-economic law. It's a law of essentially the capital cycles around what profits you can make, and therefore what are you going to invest upstream into equipment and downstream into its manufacture. So what we see is a tipping over is in fact clock speed, and not in a maybe in a gentle way, but not nearly as much in sort of the number of transistors that get made or printed. And I think that's really and if you go back to the essence of Moore's law, it's about the consumption. It's about actually the production of transistors, saying that they would double every 18 months the number of transistors. And so it's basically, your marketing problem is how do you double the consumption of transistors for every sort of man, woman, and child on the planet every 18 months, right? And as long as that continues, and I think the consumer electronics revolution is a really big demand function on that. And I don't see the demand dropping off. And so I believe that techno-economic cycle is going to continue. Will it be 18 months? Will it be 24 months? Who knows?
Right. Question over here.
So as someone who's in charge of innovation and R&D at Sun, what do you do? What levers do you have to stimulate innovation in a company that size?
Great question. So what are my levers to stimulate innovation? Dollars. It's number one. So the number one thing I can do is invest in teams. And if there are ideas, and I think those ideas have promise, I can move money over into that. And that's the capital cycle inside a small company. In some sense, I act like a venture, in a venture way in this. The other part, and it gets, celebrating innovation and ideas where Sun is a really iconoclastic company, for better or for worse. We don't believe in conventional wisdom. We like things that are different. We'll see, right? And as you dissect Sun before and after, about how profitable that is in a capitalist sense, but it's a heck of a lot of fun. And you get rewards in that way too, which is psychic rewards that I think are a lot about, back to the toiling and obscurity. Now, you really want to celebrate ideas and highlight them.
Okay. Another question.
How do you measure innovation and Sun?
How do I measure
innovation?
How do you measure innovation? Well, there aren't good direct measures of saying, is something innovative or not. I think the best measure in a capitalist thing is, so what are you returning to your shareholders, right? And so you can you can look at that from us and say, well, you're not being very innovative right now. But it's more complex than that, because what you really want to look at is what are the, for a particular technology that you've invested in, essentially what is it yielding in the marketplace. And so you back solve that. But there's a more basic thing too, like, is it cool? Is it new? For better or for worse. That's the way we look at it. This is back to this sort of iconoclasm of we like things that are different. And so innovation, in my view, is it's something different. And I wanted to come back to a little bit of the principles here. If you're doing what is conventional or is the same, or if everybody believes that's the way to go, you're not going to make as much money off of it, the ability to do that. You really do need to be doing something that's different, I think.
Great. Thank you. Yes?
I actually had a question about the environmental responsibility.
Yes.
I'm very happy that you talked about that. It's new for me here. I was just wondering to what degree does Sun also think about environmental responsibility and like LCAs and the fact that they're hardware.
So how much do we as Sun think about it? The genesis of this book was actually from my co-author, David Douglas, is the Chief Sustainability Officer at Sun. And it's been, two parts. There's sort of a part about, this is the value system of the company. It's one of, we think of ourselves as how do you be a good company? I mean, what does that mean? And certainly eco-responsibility becomes part of that. It also turns out that green is green, so you can work on eco-responsible things and make a lot of money. And you basically make that money through recovering inefficiencies or actually discovering things like, gee, don't stick the sticker on the aluminum and you can reclaim it in a way. And we end up reclaiming 98% of what we put into our products. And so it's just a really, I think it translates into a way of business. And that's actually essential, I think, if sustainability is sustainable. Right?
Great. Thank you.
So let's say I'm an engineer at Sun and I have a really cool idea for a new project. Can you describe the process at Sun for making that idea into reality?
So what's the process of getting a new idea into reality? Yeah, so a long-standing thing is really people end up with these Friday projects. I think in organizations that want to pull innovation out is you have to give slack to the engineers. And part of that slack is there's a fraction of the time that I want you to work on something, right? And go play with it and actually maybe get a couple of other people to go do it too. And then eventually if you start getting results, is that you show it to this is what I've been doing on Friday, or on the weekend, or that, and begin to show it upwards. And if it's really cool, send me an email and come let me see it. A lot of that happens, and then the money thing happens, and everybody's happy.
In the back.
One more question is, Sun is a good company, at least it used to be, and now it's scaling. And what lesson do you learn? What would you do differently?
What would I do differently? It is, so we're being acquired by Oracle. Oracle's reputation in the industry is one of extraordinary focus on the business of serving enterprise computing customers. So they're a very business-focused company. As you hear from them, and you see me, I'm just a kid about innovation and new ideas and what's cool, how do you measure it? So there's a really interesting cultural mean somewhere, right, that I don't think dilutes, but I think actually adds to it, which is get better at for Sun, this would be, the prescription is, get better at some of the harder business decisions that take place that may mean that, in fact, you're going to cut off something that looks like that you think is promising, or not do something that you think is good or different, but go against the business realities or be more efficient in structures. And I suspect that business cases will be written about that too. There's another part of just the industry of, information technology industry is consolidating in a really substantial way. And I think become part of Oracle, and it's sort of 30-some thousand people becoming part of an 80-some thousand person company, that's a big cultural injection into that. It is the way that, it is the next step in the life cycle of Sun.
Okay. Let's take a few more questions. Yes?
If the future of computing is the cloud, and the cloud favors servers,
yeah,
a traditional strength of Sun, and the biggest barrier to cloud computing adoption is speed, cloud's too slow, can Sun do anything to solve that?
So there was a sort of a hypothesis in that question that I'm not sure I agree with, which is that the barrier to adoption of cloud computing is that clouds are too slow. I don't hear that. I certainly hear concerns about security, about concerns about bandwidth and access to clouds and things. Let me just sweep through it and say it's inevitable in my mind that there will be a transition from people buying computers to buying the effects of computing, essentially a service, whether that's a service that you get by going to a website or it's that you subscribe to cycles. And in some sense, I think it's inevitable. The challenges there are, I would say, it's not so much speed, and I'll tell you what's in the center. And I said, why do I invest 10 years in some packaging ideas? Is the challenges are really around the efficiencies in which you're able to do that. And I said that the eco impact of computing is mostly in its energy consumption in servers. Well, that's where the costs are too. That's the eco equals eco in here. So if you go work on things like getting these things much more energy efficient, much more efficient in terms of resources and materials, you gain competitive advantage in what you're projecting out. And so that's a lot of the R&D is focused on that. I call it brutal efficiency in those settings. It's actually easier in the cloud sense because really the people consuming that are in some sense really professional, right? Serving a market of as you do a broader market with 60,000 customers there's a lot of variance in people's sophistication in buying. So I'd rather sell to fewer sort of more sophisticated larger customers.
Okay. We'll take one last question. Yes.
It seems that you need to make a lot of decisions that are strategic in nature about which direction you want to head the innovation in. When you have 50 or 60 ideas that come on your table every so often, you need to pick some. My question is, how and to what extent do you keep track of the bigger picture?
Yeah.
You go to conferences, read books, magazines, how do you go sit in your competitor's office, or do you talk to your friends, or how do you basically keep touch of what's not happening at Sun?
That's a really good question about, so how do you stay in touch with what's relevant? Fortunately, the marketplace that we're in isn't that big. I don't have that many competitors to look at. That's part of the consolidation that's happening. So it's really important. I encourage everyone to do this. Is you want to know your competition. I mean, even to the extent that we will, we'll go pretend we'll set up some shell company somewhere and go buy computers of our competitors and tear them apart. Right? So you understand what it's not illegal. It's just that if we bought it directly, we probably wouldn't get great service. So so you do those things, and in some sense, and this is really, I think it's an important psychological position. I'll leave people with this view, is that, as I said, innovation happens everywhere. So you want to be open to cool ideas that are happening elsewhere and figure out, how you can go take advantage of those ideas too, and how you might incorporate them in. And I'll leave you with a great Pablo Picasso quote, right? Which is, "Good artists copy, great artists steal." So thank you.
So Greg, with that, I want to remind everybody that Greg's book is on sale in the lobby.
Shameless self-promotion.
And
you can buy it.
And you could buy it.
Yeah.
And if you corner Greg, I bet you he'd almost be looking for a pen.
Yeah, right.
And so before you leave, Greg, we'd like to give you an award.
So on behalf of BASIS, STVP, and DFJ, we'd like to thank Greg for speaking here at ETL today.
Thank you.
Here's a little prize. Thank you.
Thank you very much.
Thank you. And thank you for coming, Greg.
Thank you.
Thank you.
Everyone who's registered in ETL to
For more, please visit us at stanford.edu.